Now, it's not necessary to write down all those steps every time you do one of these problems, but it's a good idea to do at least a few problems where you do write out all the steps, so you remind yourself of what you're really doing at each step rather than doing it out of habit. Do it using the rules. Don't do it out of habit. But of course, when you got a lot of them to do, you are going to fall back on habit, and that's perfectly all right as long as you know what the rules are and can check out your habits from time to time. Okay, well, x minus 3 times x minus 5. Now I'm going to abbreviate this. You know that I'm going to do x times x minus 5, which is going to give me x times x squared, x times negative 5, which is negative 5x, and then minus 3 times x minus 5, which is going to give me negative 3x, and negative 3 times negative 5 is plus 15, and then the x terms, of course, I could factor out the x on the right and get negative 5 minus 3 times x, but that's negative 8x, and we know what that means. Okay, so fairly straightforward multiplication of binomials. Another multiplication of binomials using the same procedure. X times x plus 5. X times x is x squared. X times 5 is 5x. Negative 5 times x is negative 5x. Negative 5 times 5 is negative 25. The 5x and the negative 5x in this case add up to 0, so all we have is x squared minus 25. Now, this is an instance of a fairly common occurrence where you have x minus something times x plus the same thing, and that ends up giving you x squared minus that thing squared. So x minus a times x plus a is x squared minus a squared. If if a happens to be 5, then we have x minus 5 times x plus 5, which is what we have here, and that should give us x squared minus 5 squared. Well, 5 squared being 25, we get x squared minus 5 squared, or x squared minus 25. This gives us what we call a special product, okay? So x minus a times x plus a is x squared minus a squared. And here are the details of that. X times x is x squared. Hope nobody copied that down and believed it, okay? And negative a times x is negative, well, x times a is ax. Negative a times x is negative ax. Negative a times a is negative a squared. Boy, I sure hope nobody copied that down. So we get this. And of course, then that gives us x squared minus a squared. So here are the details of why this is the case. Okay. And this can be written in many different forms. It's not always convenient to use x and a, so one alternative is to use a and b. A minus b times a plus b is a squared minus b squared. It should be very clear that this is the same as this. It's just that we've used a and b instead of x and a. So if I replace x with a and a with b, we get this. And x minus y times x plus y is x squared minus y squared. Again, if instead of a I use y, I get this. These are just two alternative forms of the same thing, and it should look familiar to you in any of those forms. And there's another, this is called a special product. And there's another special product that's quite important. X plus a quantity squared is x squared plus 2ax plus a squared. That's a pattern that you want to be familiar with. And that can be expressed in terms of a and b. A plus b quantity squared is a squared plus 2ab plus b squared, or x plus y squared is x squared plus 2xy plus y squared. You should understand why all of these are equivalent. In this case, I basically prove the thing here by multiplying x plus a by x plus a in the usual manner. And we get x times x is x squared, x times a is ax, a times x is ax, a times a is a squared, and then we factor the x out. We have a plus a times x, which is just 2a times x, and we get this version of the expression, and you could have done the same here or here.